Welcome back to the channel. Today we are going to replace this old frayed power cord on a power tool. So let's get into it. Alright, so today I'm doing this repair on a Hitachi reciprocating saw. Some people call these a sawzall. You could call it an umbrella. I really don't care. The point is, as you can see, this power cord is very clearly frayed. It's worn through and this thing no longer works. I'm gonna go over this at a high level, but just know that if you have a different brand or even a different tool type, the general repair is gonna be pretty similar and you should be able to figure it out based on what I'm showing you here. So generally what you will need for this is a couple screwdrivers, the size of which is gonna vary depending on the tool you're working on, and obviously the new power cord. But you should know that these come in a couple different thicknesses, so you're gonna have to figure out which one's right. And the easiest way to do that is look for a sticker on your power tool that says how many amps it is, or if you find the model number, you can look up how many amps it is online. The sticker on this tool is still legible. It says 120 volt 11 amp, and when you get the new power cord, you want the amperage rating to be at least equal to or higher than what is listed on the tool. So what I bought is a 14 gauge power cord. This is actually good for a tool up to 15 amps. This was $14.47, but the other popular option is a 16 gauge cord that is a couple dollars cheaper, and that is rated for up to 12 amps of power. If you buy one that cannot handle the right amount of amperage, basically that cord's gonna get very hot, and long term it could pose a fire hazard. That's why it's important to get one that's at least as heavy duty as the tool that you're using. For me, I also just wanted a thicker cord because I was using this for my yard renovation, which I'll link below. I was not going to be treating this thing kindly, so I wanted it to be a little bit more durable. But make that call for yourself, right? If you want to save a couple bucks and then risk burning down your house, that's your choice. I'm not going to be responsible for it. On a similar note, make sure there's nothing sharp like a blade or a drill bit attached to the tool while you're doing this, because if you slip up and hit that, you're probably going to have a bad day. So with those disclaimers out of the way, the power cord goes in here, the base of the tool, and I can see this seam line in the plastic that leads up to it, and that tells me that those are pieces that can probably separate. Based on that, I can tell that these two halves have to be fastened together somewhere, and by looking around, I see a number of screws that go around this handle piece, which seems to go from where the hand grip is to about the mid body of this saw. So based on what I can see, this entire section is one piece, and I'm expecting it all to come off together. The screw locations are all pretty obvious. They're all exposed here. I'm going around and removing these with a hand screwdriver because really you don't want to use too much force. For the most part, power tools have a full plastic body, which means the screw is going into another piece of plastic. And if you use something like a power drill to remove it, there's a chance that you basically overpower it and you're going to strip it out and it won't go back together at the end. I'm not saying that's a guarantee, but it is a possibility, and that kind of defeats the whole purpose of you trying to fix it if you can't put it back together afterwards. Also, if your dog likes to come in and take a sniff while you're working on stuff, it's much lower risk to not have a power tool running in her face. But getting back to it, there were 6 screws that I removed holding this housing together. However, there are also sometimes plastic clamps that are built into the housing that hold it together on the inside. You don't want to necessarily just rip this thing apart immediately. Use a little bit of finesse as you try to slowly work this open. For me, this was not coming apart easily. I found this one more screw on the bottom and I thought, hey, maybe that's holding it together. And that screw was actually just holding a spring-loaded fuse. I did not need to remove that, and it shot out into my face. But after a little bit more poking and prodding, I found where that front seam was. I was able to lift that up a little bit with my fingers and then fit a screwdriver under it and slowly started separating it. You just want to lift it slightly, move the screwdriver a little bit farther down, try to pry it there a little bit. Again, not too much pressure, and slowly work your way around the entirety of that casing until you find that one area that's sticking together. And in my experience, that typically tends to be around the grip. So looking at this piece here top down, you can tell that this rear grip is actually a single piece that goes over both halves of the housing. And really, it's acting like an external clamp to hold these together at the back, which is actually a pretty brilliant idea. The only problem with this being you now have to figure out how to remove this little butt plate, and on every tool they seem to come off a little bit differently. What I have seen most commonly, and what was true for this one, is that plate slides straight off of the back. Every now and then you'll get one that slides up or down, kind of in the direction of the handle. And honestly, if Google can't tell you the answer, it's just gonna be a guessing game. And another quick tip is, because this is kind of clamping everything together, if you remove all the screws and pry off the body too much, it's really just gonna add extra friction into that grip. You might have to push the body back together and maybe put a screw back in order to get that thing to move. The other thing that I tried, which I do not recommend doing on your own, is using either a really thin screwdriver or a knife blade to try to get get in there and pry off the edges. Sometimes they've got a little bit of glue, but this one is just really caked up. So this is probably the first time that this thing has ever been removed in the entire life of this tool, and it did not come easily. I know I said to be a little bit careful, but there are times you're going to need a little bit of force, and this was certainly one of them. But after almost completely annihilating my camera and tripod, look at how easily the rest of this housing comes off. Isn't that nice? So very nice indeed. Glad I almost stabbed my hand for that. But looking at the inside now, you can see where the power cord comes in here at the bottom of the tool. There's this little clamp with 2 set screws, and following the wires up, they go into this connector block that is next to the trigger. So before you touch anything, I would take a picture, or like, 12, of how everything goes together and sits within this housing, because if you don't have it exactly the same, you're gonna have one hell of a time getting this closed in a minute. And once you have sufficiently documented everything, you can start pulling the pieces apart. The trigger mechanism and this connector block came straight out. Normally the clamping force of the housing is the only things keeping these in place. And as you can see, this is also very dirty. I am gonna spend some time in a little bit to clean this all up before I put it back together, just to try to prolong the life of this. Next, we're going to remove the old broken power cord, starting by removing these 2 screws in the clamp that are holding it into place. Then we're going to play a game of follow the wires to see where they are plugged into on this connector block. You'll notice one of them is white and one of them is black. That is very important, otherwise you are going to wire this backwards, and I don't know what happens, but I also don't want to know because it will probably break stuff. The other thing I very quickly noticed here, which I probably should have caught earlier, is that there are only 2 prongs on both the plug and the power wire going into this, whereas my new cable has 3 prongs. That's because the new cable has a grounding wire, which this specific tool does not have. But at least for me, my house was built in the 1950s, nothing in here is actually grounded properly, so regardless of if it's connected to anything, it's not going to be doing me any favors. But anyhow, starting with the old power cable, what you're actually going to do is note where the white and where the black wires go into this connector, and that's of course assuming that you have a connector. If you don't, you're going to have to solder the new wires in line, but there are a bunch of really good tutorials out there on YouTube on how to do that. But for the old power cable, once you have either remembered or documented where the white and black cable go into this connector, there's this little tiny set screw that holds it in place on the side. You're going to loosen both of those up and remove the old power cord. And again, these might be a little bit caked on from years of sitting, but they should pull out with relative ease. Now normally I would recommend taking out one wire and then immediately putting in the new one from the new cord, but the reason I don't do that is because first you want to take this thick rubber grommet off of the old power cord that protects it where it goes into the body of the tool. You have to slide this over the new power cord before you install it, otherwise it's not going on there. And if you don't, it's not going to seal properly at the base of the tool. It's going to put more strain on those wire connections, and it's going to make it more likely to fail over time. And as an added bonus, it won't be as watertight, even though that's much less of a concern than just ripping the wires out while they're plugged in. But anyhow, that should slide right over your new power cable. You're going to pull it down low enough so that you have a couple inches of wire sticking up. And the easy way to check this is just line up the boot with where it's supposed to sit in the housing, because usually there's a cutout for it, and make sure the wires fully reach whatever connector that they're supposed to go to without any strain. If the wires are really stretching to reach, that's bad, but also if you have too much wire in there, this thing's not going to close, so try to find a happy medium. And with that figured out, we're now going to do the most mind-blowing part, which is going to be putting the new white wire where the old white wire was, and then tightening down that set screw, followed by, you guessed it, putting the black wire where the old black wire was, and then also tightening down that set screw. Now personally, I like to get these things really snug but not overly clamped, because I don't want to really crush the wires and potentially break them, and I also don't want to strip out the screw in case I have to do this again long term. But the wire should be fully seated up and in the connector. You really shouldn't have a whole lot, if any, exposed, and you should be able to give it anywhere from a gentle to a medium tug without the thing coming out of the connector block. And where that leaves us now is having this one little pesky green wire left that we have nothing to connect to. I'm going to show you something on this particular tool that makes this not a problem, but this isn't going to be the case for everyone. But looking at the original label, you see this on the top left. This is called the box within a box. That means that this tool is double insulated, which means the grounding wire is not really required. Basically, they accounted for that in the design and built in the electrical insulation, so you should be fine. So if you also do not have a designated ground on your tool, what you're basically going to do is just try to place this somewhere when we're reassembling this so that it will not short out. That means it's going to be bent in a way that it is not poking that connector box, because that is pretty much the only situation in which it will suddenly have power going to it, which is not a good thing. But first, we're going to put this connector box and the trigger assembly roughly back in place, make sure our wires are all the right length without any of that strain that I mentioned earlier. You can also see that I cleaned off a lot of the gunk off camera, because quite frankly that is not exciting to watch. And once we're happy with all that, we can retighten the clamp that's going to hold this cord in place. And the easiest way I found to do this was to pre-start both of the screws, then put the full clamp down and then tighten it up. And my other pro tip is that you shouldn't fully tighten one screw at a time. You should kind of go back and forth between the two of them and slowly increase the pressure in equal amounts on both sides. You don't want to fully pinch it on one side only, that just runs a higher risk of crushing one of the wires. With the clamp installed, that connector block can now go back to its rightful place, and the last thing we gotta deal with is this pesky green wire. I'm folding it down here towards the bottom part of the panel. There are no open exposed wires like there are going into the base of that connector block, and beyond that you can see I am wrapping it fully with electrical tape. You really don't have to get fancy with this, you are just trying to prevent any electrical contact from occurring with any of the other exposed wires in this housing. So honestly, if you like to live real dangerously, you could probably just tuck it down if you know there's nothing else around there that it can touch, but for me it was worth the extra insurance of insulating it with the electrical tape because I already have it on hand, and honestly it only took a couple extra seconds to do. I then just tuck it in here under this nest of other wires, that way I know it's not going to be sticking up too much and preventing this from closing. And with the new power wires going into the connector block, they're not conditioned from years of sitting in one shape. That connector block might lift itself up a few times, don't worry about that, you're just going to have to push it down and try to finagle it as you're reassembling this thing, which also happens to be the next and one of the final steps. You can see I put that back into the place with the trigger assembly. I held those down and then carefully slid the rest of this housing over the top. But as you can see, this might not always go as planned on your first attempt. The housing didn't want to fully seat the first time I tried this, so if you're having the same issue, don't just force it together. It's usually a wire that's in the way, and you're probably gonna pinch it if you just start clamping stuff down. A little bit of lift of the housing is not the end of the world. Just open it back up, do a quick inspection, make sure nothing is really sticking up. For me, there was nothing really obvious, and the only potential contender was really the trigger assembly on that top part of the housing where it was sticking up still. So I quickly took that out, made sure there was no debris, everything was clear, and then quickly reassembled it. And the second time I put the housing on, I did give it a little bit more of a push, but I didn't really feel any resistance, so something was lining up a lot better. But once those halves are happily mated, you are good to start screwing this tool back together. The entire process is just going to be the reverse of the disassembly, starting with sliding that handle back on at the rear to clamp these two halves together, followed by, in this case, reinstalling those 6 screws, as well as reinstalling any spring-loaded magnets or fuses that you happen to pull out unnecessarily. But I also highly recommend checking everything prior to getting all the screws in, because as I found out when I was most of the way through this, there was a little bit of wire here on the bottom that was pinched in the housing. Fortunately, this time though, I didn't have to fully rip everything apart. I could just use my extra small screwdriver and jam it in there, and that seemed to fix most of my problems. And with that, the final step after you finish the reassembly is to plug this in and make sure it works without lighting itself on fire. Okay, truth be told, realistically, it's not going to light itself on fire. It would probably just not run at all, but let's see how this goes on my first attempt. And look at that, it is a Christmas miracle in the middle of July, and it worked on the first time. So that's how I got a working reciprocating saw for $14.47. But I want to thank you guys for watching this episode of Take Something Broken and Make It Less Broken, and I will see you next time.